Well, hey everyone, Patrick here, and today I'm recording a video about TypeScript. It's a fun challenge that I had with a friend yesterday, so I'm gonna try to explain it and what is the problem here and why we can learn a lot about type mappings with this example. So um, basically, we have a data structure here, this object right here. You can see that it's got a few keys, X and Y, and it's basically required is a Boolean property, and the type could be string or Boolean. So the idea is to map this whole data structure into this data structure right below. So we have the same keys for the object, but um, the values differ. So the value is not the whole object, so it just picks a property, the type property for each one of these fields. And the tricky part here is that we have this required field that it just means this property should be required in the final data structure, and if it's false, the property is optional, like with this y here, it's an optional property. So how do we achieve that? So you can see that this whole data structure here is defined as this fields type. So it's basically a record of string to each one of these objects data structure. So that's what we have here. That is the string is x or y, and each one of these types here they match this type here. So this is fields. It's the whole object, the A object. Then I have declared a function here to simulate a function that would transform from one data structure to another, just for the sake of typing. So a to b is the name of the function, and it gets a generic named t that extends fields. So when you have extends here, it basically means that you want an object that contains at least the fields specified here. So extends means that you could have more properties in the object that is passed, but this object is required to have these properties right here. So if I add another property here, it wouldn't complain about it. So if I used like just the plain type here instead of the generic, it would complain because it would not be the same. So that's why we use these extend notations. Okay, so a to b gets a t that extends fields. So this t now is basically our whole object right here. And it is defined as the parameter a, and it returns a mapped field of t. So mapped field is basically the type definition for this desired state, the desired result that we want. So we can see now the same type definition here, the t extends fields for the generics. And what we are doing right here is that there is this intersection. So this whole thing, it just extracts the optional properties, and this whole thing right here, it extracts the required properties. So if we make an intersection of the both of them, like if we merge the properties and values, then it should get the two categories here. So that's why this is happening. There are two of these types. So we could actually abstract it probably, but I don't know. It looks okay for me this way. So the first part, let's take a look at how it works. So this is, I'm actually iterating over the keys of t. So for each one of these keys, x and y, we have this property. So this should be x in one iteration and y in the next iteration. And well, for each one of these properties, we have this s. So s means that we are mapping them. So there is a type transformation here. It's like, you can think about it as a .map in JavaScript. So I think it's easier to think about it this way. So, well, I'm basically using this as to, so if it is a required object, it returns never here. So what that means is that if it contains the required true property, it means that it should not be an optional property, because there is this operator here, this plus question mark. This means that for each one of these properties, we are creating just optional ones here. So we're iterating over them and adding the optional modifier here. So all of the properties inside this object are optional. That's why I'm eliminating the ones that should be required. So if it has required true right here, so this is the extent here. So T property is the actual property we are currently iterating. If it extends the required object, then it returns never. So never just means that it shouldn't exist. And right below we have the same thing, but it's the opposite. Like we reiterate over each one of the properties, and we check if it extends the required object, it actually returns it. And if it doesn't extend, if it's an optional property, it returns never. But we don't have the question mark operator here, the plus question mark, because these ones are just the required properties. So that's what happens here. And just the final part here, after the semicolon here. No, it's actually after the column here. There is this T property type. So we're actually passing the value for each one of these properties, which is the type, like it's Boolean or string. So that is the result. So if I type b dot, there is x and y is optional. So I could add maybe z here and just play with it. Let's try it, z, and let's make it required and Boolean. So if I make b dot, now we have z here, and z is a Boolean that is required. So cool. Now that's it for this exercise on mapping fields. I hope it was helpful for you, and well, bye bye.